This episode is brought to you by VPP Simplified. Now you can get element by element tracking and guidance for your VPP journey. Every aspect of the VPP requirements in one easy-to-use interactive spreadsheet. Achieving VPP star status can be tough, but understanding what it takes to get there can be simplified. This VPP Gap tool will help you do that. Go to vppsimplified.com for more information.
Welcome to the Safety Pro Podcast, where we help you manage workplace safety one episode at a time. And now, your very own Safety Pro, Blaine J. Hoffman.
Welcome to another episode of the Safety Pro Podcast. In this episode, we are going to talk about machine guarding. We're going to talk about the general requirements. We're going to talk about some definitions of terms you need to understand when you're talking about or considering machine guarding of some type. And we're going to talk about, the 5 simple things you can do to ensure you're in compliance with machine guarding requirements. They're real simple. They're 5 simple steps. And a lot of folks still get this wrong. They try to look for wiggle room, gray areas. It's real simple. The simpler you can keep it, the safer your workplace is going to be. But you're also reducing the risk. Keep it simple. Don't try to look too deep into some of these things. We have language that's clear and direction and instruction that's clear, and I'm going to go over that with you as well. Okay, so we know, moving machine parts, right, have the potential to cause, severe workplace injuries. I mean, things like crushed fingers and hands, amputations, burns, even, injuries to the eyes and face that could lead to blindness, things that are very serious. Now, these safeguards or machine guarding are an essential, aspect of protecting workers from those types of hazards, which are preventable, by the way. So, any machine part, function, or process that may cause injury has to be safeguarded. When the operation of machinery or accidental contact could injure the operator or anybody else in the vicinity that's working in the area, the hazards have to be eliminated or controlled. So we start with OSHA's machine guarding standards, right? And they apply to any employers having employees exposed to dangerous moving parts. As far as regulatory citations go, you can look at general requirements for all machinery. This is OSHA's general requirement for all machines and machine guarding, right? Sort of the catch-all standard requiring employers to protect employees from dangerous moving parts and to guard points of operation. OSHA also has some machine-specific requirements or standards that are covered elsewhere in the OSHA, regulations, right? This is woodworking machinery, 29 CFR 1910-213. There's also 215, abrasive wheel machinery, 216, mills in the rubber and plastics industry, 217, mechanical power presses, 218, forging machinery, and 219, mechanical power transmission apparatus. All of those contain more specific, narrow requirements given the type of machinery in that standard. So let's talk about some key definitions so that you understand what you're talking about. When you hear somebody say, we should put interlocks or light curtain, what those are and are not. We'll start with fixed guards, right? A fixed guard, that's a permanent part of the machine. It's not dependent upon moving parts to function. It can be constructed of sheet metal, screen, wire cloth, bars, plastic, or any other material that is substantial enough to withstand whatever impact it may receive and to endure prolonged use. This guard is usually preferable to all other types because it's relatively simple. That's why. And it is, and a lot of manufactured equipment will come with fixed guards. Interlock. Now, when this type of guard is opened or removed, the tripping mechanism or power automatically shuts off or disengages. The moving parts of the machine are stopped, and the machine can't cycle, actually, or be started until the guard is back in place or that interlock is closed. An interlock guard could be, electrical, mechanical, hydraulic, or even pneumatic as far as power goes, or it could be any combination of those. Interlocks should not prevent, inching by remote control if required. So, slowly moving or cycling in inches or less the machine. Replacing the guard should not automatically restart the machine. And to be effective, all removable guards should be interlocked to prevent occupational hazards. It's always a good idea that if you have removable guards that, the operator could just grab with two little handles and slide off and over the area of operation, that be interlocked. We also have photoelectric or light devices. Light curtains or light sensors are commonly used term. The optical presence sensing device is what that is. It uses a system of light sources and controls that can interrupt the machine's operating cycle if that light field is broken. If that's the case, the machine stops, it won't cycle. This device must be used only on machines which can be stopped before the worker can reach the danger area. So we talk about time and distance. If you have a machine that when you break, disconnect the power to stop it, and it continues to cycle down, so many rotations or so many inches of movement on a conveyor or belt or something like that, you have to basically time from the point where you break that light curtain, moving your arm inwards, the average operator, the average, motion of reaching in and to grab something, you have to move that light curtain back far enough to where when you break the plane, that light sensor, that your arm or body part doesn't continue to move and contact the moving parts. It should be able to stop by the time your hand or arm or whatever's reasonable for that scenario. You have to time that. So you have to have time and distance, right? I hope that makes sense. So that's how you would adjust those and place those on a machine. We also have point of operation. OSHA makes reference to the point of operation. Safety folks, we talk about this a lot. You have to start at the point of operation and then go assess your machine for any other exposed or moving parts. That point of operation, that's the point of equipment on your equipment that the work, like cutting, boring, bending, where it's actually applied to the material. With a few exceptions, the point of operation has to always be guarded. That is incredibly important. You start there, where the work is applied to the material by the machine. That's the point of operation. There's also a power transmission apparatus or device. This is all the components of the mechanical system which transmit energy to the part of the machine that's performing the work. So now we're kind of backing up a step, right, from point of operation. So these could be flywheels, pulleys, belts, connecting rods, couplings, cams, spindles, chains, cranks, gears, cogs. It's anything that is driving the rotation or the movement or powering that point at which the work is being applied to the stock material. So that's considered power transmission apparatus or device. You may hear of pullback devices. This is not as common anymore, but we see them in some industries still to this day. A pullback device utilizes a series of cables. They're attached to the operator's wrists or their hands, even their arms in some cases. And this type of device is primarily used on machines with stroking action, right? So when the slide or ram is up between cycles, the operator is allowed to reach in and pull out a piece of material or put a piece of material in. That's accessing the point of operation. When the slide ram begins to cycle by starting its descent, a mechanical linkage automatically assures withdrawal of the hands from the point of operation by pulling them back. Not very popular among operators, but it was very common years ago. You also have restraints or holdback devices, right? They utilize, sort of like pullback devices, they utilize cables or straps that are attached to the operator's hands at a fixed point. The difference here is you have to adjust the cables or straps to let the operator's hands travel within a predetermined safe area. But, there is no extending or retracting action involved. So it's a leash, essentially, is what you've got. Consequent to this is that, hand feeding tools are often necessary if the operation involves placing material into the danger area, because you're supposed to adjust those restraints to where no part of your body gets into the point of operation. Okay, we also have self-adjusting guards, right? The openings of these barriers, they're determined by the movement of stock. As the operator moves the stock into the danger area, the guard is pushed up or away or to the side, providing an opening which is only large enough to admit the stock. After the stock is removed, the guard returns to the resting position. Now, that guard protects the operator by placing a barrier between the danger area and the operator. They can be constructed of plastic, metal, other substantial material. Remember, it's just got to be durable enough, right? Self-adjusting guards offer different degrees of protection. So a table saw with the adjustable guard that raises up when you push stock into it. Obviously, if you push your hand into it, you're still going to get there. So when they say they offer different degrees of protection, at some point it's not really a physical, preventing you from physically contacting that rotating part. In this case, the blade. You can still shove your hand in there, and that's why you use push sticks and things like that on the stock that's getting close, to the rotating blade. And close meaning it's going to be your hands or fingers are going to be placed underneath the blade that normally would be closed. Once you get into that imaginary area with your hands or a body part, you want to use push devices or things like that. So you do have to do some assessment here with self-adjusting guards to make sure that we are completely protected. Ooh, the old two-handed control. We're going to talk about this one for a moment. This requires constant concurrent pressure by the operator to activate the machine. This kind of control requires a part revolution clutch, brake, and a brake monitor if it's used on power presses. So that's key. Now, with this type of device, the operator's hands are required to be at a safe location, in this case, on the control buttons, and at a safe distance from the danger area while the machine completes its closing cycle. Two-handed operations are key. Man, I have seen super glue, duct tape. I've seen all kinds of stuff where somebody's got one button, always down, and they would hit the other button with one hand while, trying to get their hand in there to speed up, the cycle time of the machine and how many parts they can produce. Luckily, machines have evolved over the years, and they know when you're doing that. If you have one depressed constantly, the machine won't cycle up, right? It won't. So they both have to be out, and then they both have to be concurrently pressed. There's things like presence sensing devices that will sense an operator's presence. Either it's a mat that has pressure sensitivity that's connected to a machine where it won't operate if you're standing on it, or the opposite. You have to be standing on a mat in order to operate it. That means you're standing away from the area. I've also seen folks put a toolbox on this mat and then be able to operate it reaching over and still staying closer to the machine to be able to speed up that cycle time for how many parts they produce. So you have to assess what makes sense. You have to build that safety culture. You have to address those things. So that was two-handed control. Two-handed trip, that requires concurrent application of both the operator's control buttons to activate the machine cycle, after which the hands are free. This is usually used with machines equipped with full revolution clutches. The trips have to be placed far enough from the point of operation to make it impossible for the operator to move his or her hands from the trip buttons or handles into the point of operation before the first half of the cycle is completed. This is where, with two hands, you don't need constant pressure for the cycle before you can lay off. You can just touch them and it starts it. So you have to move the two-handed trip controls far enough away to where you hit it and then you walk over to the machine and it's already finishing its cycle. Okay, those are common terms that we see in here, and devices we see in here about in machine guarding. So it's important for you to understand sort of, the definition of those terms. We'll get into an e-stop as well here in a moment. I've saved that one for later on the backside of the episode because, they're common. They're the most common, device that you're going to see. And we're going to talk about what it is and what it is not in terms of machine guarding. But I want to get into the 5 requirements you have under any of these standards as an employer, that if you follow these 5 requirements, these 5 steps, if you will ensure that you're in compliance. You will be able to address in a very simple way and straightforward way these types of hazards. Before I get into that, I want to talk about our partners in safety. Now, should an emergency occur, whether it's related to machine guarding or electrical hazards, doesn't matter. If there's an emergency that takes place in your facility, let's say a fire or a chemical spill, and you need to evacuate, how are you able to manage the roster of employees that you need to account for during that emergency event? Well, this is where, if you're wondering yourself, now it's hard, it's very difficult. We have rosters, we have clipboards, but they're never up to date, and nobody ever remembers to grab it. If these are the problems that you're having with the old manual way of managing emergency evacuations, then you need to know who's on location. Who'sonlocation.com. This is it's a complete suite of software tools that you use to manage visitors, contractor management, even employee time, but also evacuation management. So I want to talk about that last one for a moment. Who's on Location's evacuation management, it allows you to verify people are safe before emergency services put their lives at risk going and looking for folks. You have a roster of employees, and any supervisor with either a tablet, an iPad, even a computer, or even their smartphones of any type, Android, Windows, iOS, doesn't matter, because these are web apps that they use, so they work across all these devices. You can grab your cell phone outside the building, and you can create an event in the Who's on Location evacuation management web app, create an event, and then you could start checking off people right there on your phone, that all of the folks that are on that shift appear on this list, this roster. And you could just swipe them off the list when you're verifying that these folks are here. Anybody that you can't verify that haven't made it to the rally point yet, they haven't made it around to the back, from the back of the building to the front where you can physically see them, you can text them or call them right from that app. If you text them, you can send an SMS text out to all the folks that are left on this roster that you have to check off. And you can have these predetermined texts already written and saved in the system. But it'll send a text, and if they reply with the word safe, they're automatically removed from the roster list. If they reply with anything other than the word safe, an alert goes out to all the other app users, other supervisors, whoever are using the app, and that they can go and see if they have this person accounted for in their area or location, or we can send out an alert that this person may need help or assistance. So it's a digital means of managing an evacuation in a time where we're increasing our numbers in our spaces, the types of facilities, and we have multiple buildings. Even on one location, we may have several outbuildings that requires multi-building evacuation in certain events or even drills. This allows you to keep track of all of those folks, even in multiple locations. I want you to see the features for yourself. Go to who'sonlocation.com. Check out all of the resources they have there. The apps, they're explained. All of the services are explained in detail. There are some explainer videos as well. But what's more important is if you get this and actually use it. If you can actually put it in your hands, go to the website on the computer and start creating your rosters and loading some folks in there, and use it and do a couple of drills and test it out. You can do this completely free. No credit card required, no catches, no gimmicks. Just sign up at who'sonlocation.com for a free 30-day trial. And that is not a limited access. You get unlimited access to all of the apps and services. And if you do decide to stay with the service, everything you've done up to that point goes with you. So you get to save all of your employee rosters and things that you've created while trying this out. Look, go to who'sonlocation.com, get the 30-day trial. I did. It's wonderful. You're not going to be disappointed. And tell me what you think. If you've already gotten the trial or are in the middle of a trial or you got the service, shoot me an email. Let me know what you think. I would love to pass that along to the fine folks at Who's on Location. All right, the next incredible partner we have here at the Safety Pro Podcast is Mighty Line Floor Tape. They are the official floor marking, floor sign company of the podcast. They know how important safety is to your organization. And you can tell, just look at the breadth of the Mighty Line Floor Tape products and services. If you're looking to organize your workplace, whether it's a 5S initiative or just mark the based on the minimum OSHA requirements that are out there, that you just need to mark your facility for certain hazards. You need to mark where certain things go. You would like to mark exits, the floor around underneath where the fire extinguishers are hanging on columns, or eye wash stations, or chemical storage area. We want to put some tape down. We want some floor signs for forklift traffic. Doesn't matter. Go to mightylinefloortape.com/podcast. Fill out the form. Get a free sample of the floor tape. Here's what you're going to learn about their floor tape. Okay, first off, it is 7 times thicker than the average floor tape. Its beveled edge makes it more durable for forklift traffic. I mean, all of these things that they've put into their product, it makes it the most durable floor tape in the industry. Peel and stick, it removes easily with very little residue left behind. It's an incredible product for you to use, especially in an ever-changing sort of layout situation where you're frequently changing the layout of your facilities. Nobody likes to scrape all that tape up or paint. Don't even get me started with paint, right? If you're still painting, you're nuts. Look, just go to mightylinetape.com/podcast, get your free sample. And as far as their floor signs and directional signs, you can even use your own high-res logos and images in the floor signs. They're just as durable and easy to place and remove and relocate. Go to mightylinetape.com/podcast for a free sample. While you're there, you can check out past episodes of the Safety Pro podcast. Great partners for us. We're proud to be partnered with them in safety. They can help you improve safety in your facility as well. All right, so these are the 5 things that you need to do to improve or be in compliance with machine guarding standards. They're real simple, too. I'll go through each one of them one at a time here. Number 1, determine the types of machinery in the workplace, okay? Then determine if there's a machine-specific standard, like woodworking, things like that. Or if the equipment is covered under the catch-all guarding requirement, 1910.212. Then you just follow that applicable standard. Number 2, provide one or more methods of machine guarding to protect the operator and other employees in the machine area from hazards, such as those created by point of operation, in-running nip points, rotating parts, and even flying chips and sparks. Don't forget those. You're required to guard the area from those. Now, you have to note that some of the machine-specific standards actually prescribe specific safeguarding measures. So you may be driven to one type of protective measure based on that machine-specific standard. So that goes back to number 1. You should be reading that machine-specific standard if you did number 1 correctly, which is determine the types of machinery in the workplace. So that was number 1, determine the types of machinery in the workplace. Number 2, provide one or more methods of machine guarding. Number 3, ensure the point of operation of machines is guarded. You have to then verify. You have to ensure that that is guarded. Number 4, ensure necessary guards are affixed and secured. So you're going to need to do inspections and audits, set up a machine guarding audit or an area audit, include this into that, rhythm that you have set up to assess your work areas. Make sure that they continue to stay in that condition, right? Fixed and secured. And number 5, anchor machines that are designed for a fixed location to prevent walking or moving, or rocking, things like that. So that's it. It's pretty simple. If you follow those 5 steps, you'll catch everything. But you have to do that with all of your machines. It's also good to get a list, an index of, all the machines that you have, whether they're portable or fixed, in those 2 categories. Pedestal stands are a good one. People always ask about those. Yeah, it's always a good idea to bolt that sucker down if you can, because it could move, it could rock. You're pushing a piece of material on a buffing wheel or a grinding wheel, which you shouldn't be, but we know operators can, or leaning on the rest with a heavy piece of stock. It could wobble, it could become loose just sitting there on the floor. Bolt that thing down. So I mentioned earlier about e-stops and the reason why I wanted to separate these 2. Folks often confuse an e-stop with, machine guarding. Basically, an e-stop or emergency stop device, they quickly stop a machine's movement. They can prevent or lessen the severity of injury to a worker who becomes entangled in dangerous parts. But unlike machine guarding, they don't prevent access to that area. An emergency stop is just that. An emergency is taking place for some reason, doesn't matter what, but I need to stop this machine, and it requires somebody to go up and hit that e-stop. So OSHA, they don't have a comprehensive regulation on e-stops. Rather, there are several machine-specific regulations that address e-stops to varying degrees, as well as just a general requirement to keep workers safe around moving machinery. So you're gonna see e-stops referenced, in general, but there is no specific standard addressing emergency stops. But I wanted to talk about e-stops separately because of that, what I had already stated. It is not a machine guarding. It doesn't satisfy machine guarding requirements. Something else you want to note, they don't have a comprehensive regulation. Therefore, there is no specific standard for emergency stop controls, right? So let me tell you where you will find, emergency stops being addressed in varying degrees. Which parts of the standard? 29 CFR 1910.144, that's A1III, the safety color code for marking physical hazards. So you have a very specific color code and marking requirement for e-stops. You have 1910.216, mills, calendars in the rubber and plastics industry. So that's where you would go for machine guarding for that industry. Also 217, mechanical power presses, and 261, pulp, paper, and paperboard mill conveyors. And then, of course, you have what OSHA would use is the general duty clause, the catch-all for things that you should be doing anyway. That's where you're going to find those regulatory citations. Now, just to be clear so that we're on the same page, emergency stop devices are designed to be used in reaction to an incident or hazardous situation. And as such, they're not considered machine safeguarding, right? These devices like buttons, rope pulls, cable pulls, or even pressure-sensitive body bars, they neither detect nor prevent employee exposure to machine hazards. Rather, they initiate an action to stop hazardous motion when an employee recognizes a hazard and activates them. That is key. Do not let operators assume, or supervisors or others, or yourself, assume that an e-stop is what you need on that machine to protect employees. It doesn't satisfy the machine guarding requirement. Similar to machine guards, there are 5 steps you can take. They're very similar. 1, and remember, this is for determining whether or not you need e-stops, right? 1, assess machinery for the necessity of e-stops. Now, most new equipment will have this feature built in. Some OSHA standards, like those for mechanical power presses, they actually require an e-stop. Most dangerous equipment where workers could be caught, trapped, or otherwise injured should have an e-stop. Okay, so determine the necessity for e-stops on all machinery, number 1. Number 2, ensure e-stops are installed and maintained properly. Equipment manufacturers generally provide this information, but you can buy e-stops and have them wired and installed by an electrician, mechanical power press, technicians, or even machine operators that are versed in machine maintenance, that are trained to do this type of work. You can actually install e-stops, but they have to be installed and maintained properly. Number 3, ensure e-stops are within immediate reach of operators who may be exposed to dangerous moving parts. So if your arm could be wrapped up in something and you're able to access it, I would take a step back off of e-stops and say, well, how come we're not guarding that area physically to begin with? But for some reason, if there's a point of the process that allows you to not guard it for some reason, and an operator could be entangled or get caught, that you need to locate it within reach of that area. That's key. Number 4, color e-stops red. They also have to be marked with the word stop. Number 5, do not place rings or shrouds around e-stops such that intentional activation could be interfered with. So I've seen this a lot where you locate them in an area where they'll get bumped for some reason, one reason or another, and people want to put a little plastic, clamshell cover on them where you have to flip it up to hit it. Can't do that. So, I would, if somebody's bumping it frequently enough to where it's causing a problem, I would say, you want to reevaluate the area and say maybe we relocate that still in the vicinity, but we relocate that to make it easier for the operator to do their normal job without accidentally bumping that thing. So that's it right there, those 5 things. Assess machinery for the necessity of e-stops, ensure e-stops are installed and maintained properly, ensure the e-stops are within immediate reach, color code and mark, and also don't, cover or prevent access to the e-stop. Okay, so let's get to some frequently asked questions before we wrap up this episode covering machine guarding. These are questions that, you may have had, I've gotten, OSHA gets these a lot as well. The first one, do machine guards need to be color-coded? In short, no. There are no requirements to color machine guards yellow, orange, or any other type of color. According to 29 CFR 1910-144A3, yellow shall be the basic color for designating caution and for marking physical hazards such as striking against, stumbling, falling, tripping, caught in between. However, this regulation was not meant to state or directly implicate that all machine guards be painted yellow, just that if you're going to mark a particular hazard, it has to be yellow. So I hope that makes sense, right? According to the safety color code, the ANSI Z 535, I believe, .1, I think the 1998 is the current one. Yellow is the basic color for designating caution and for marking physical hazards. So that's where we get that. So it also designates orange for identifying hazardous machine parts, which may crush or otherwise injure, as well as for identifying exposed parts. Orange is also used to indicate warning under that standard. So there are later additions to the ANSI standard, right? And they no longer contain the safety color meanings, but that's where OSHA's getting that's what's driving the OSHA recommendation for marking stuff yellow. So painting machine guarding yellow or orange or any other color, although it's not required, it can encourage employees to not remove guards unless they're trained or authorized. It also makes it easier to inspect to make sure guards are in place, especially if you're in a particular, operation or process that can be messy. Painting them yellow or, high-vis color type of color makes it easier to spot them. Another question, does the entire guard or just a small portion of the guard need to be color-coded? So that's, natural next question is, okay, the whole thing or what? Well, look, a small, here, I've got a couple questions. Let me read a couple of these. Would a small strip of yellow or yellow on black striped tape installed along the leading edge of the guard work, or a piece of orange tape applied to the inside cover of the guard meet the intent of the standard? Now, again, 1910-144A3, it states yellow for marking physical hazards, but it doesn't specify where or how much of the machine or the physical hazard needs to be marked. It doesn't state that. So it's a performance-oriented standard. So your first question is, do I have to color code things? And they're like, well, it's not specified for machine guarding that you color code them. But elsewhere in the OSHA standard, they talk about if you're going to mark, hazards, physical hazards, it has to be yellow. Then you get to the next question. It was like, well, does the whole thing have to be marked or just part of it? That whole thing. It's performance driven, right? It's a performance oriented standard. It's left to the discretion of the employer to determine first the necessity of color coding and second, the optimum location and the extent of the markings. So you have to do that. It's on you. Now, just to reiterate what the standard says, yellow is used to identify physical hazards. If the guard of a machine does not present a physical hazard, like tripping, falling, struck by, caught in between, then there would be no need for color coding. Remember, we're talking about the guard. When you paint the guard, under the standard, you're saying that the guard is presenting some sort of hazard. not the blade. No, you're not going to paint the blade yellow. So that's why they're saying the machine guard itself is the guard against the hazard, not just marking visually that, hey, there's a hazard here that you could bump up against when you're walking by. So if it's something that protrudes out a little bit in a common area where folks walk around, things like that, you could put a bumper on it. You can mark that yellow, mark the floor around that area yellow so people walk around it instead of cutting that corner short. That's what they're talking about here. But people conflate these two things, machine guarding and then painting all the guards. I've even had people say, hey, we have to paint these guards and touch them up. They're getting faded or scratched or chipped. We're going to get a citation. No, you're not. For what? So keep that in mind, right? Another question, should workers who operate table saws or other equipment with both sharp edge hazards and rotating parts be encouraged to wear gloves? This is a good one. It comes up a lot, wearing gloves. The PPE regulations, they require personal protective equipment for eyes, face, head, and extremities. It says, shall be provided, used, and maintained in a sanitary and reliable condition wherever it is necessary by reason of hazards of process or environment, chemical hazards, radiological hazards, or mechanical irritants encountered in a manner capable of causing injury or impairment in the function of any part of the body through absorption, inhalation, or physical contact. Whew, man, that's a mouthful. So, unless the use of gloves creates a greater hazard to the operator, it is not a violation to use them while operating rotating equipment. Now, you're responsible for evaluating each situation to ensure that those work practices don't increase hazard for employees. But I will tell you, just as an example, like the Department of Energy and a few others, they recommend that gloves not be worn when employees must work in proximity to rotating parts and equipment like drill presses, things like that. It's very common to prohibit, operators from using gloves, wearing gloves, having loose sleeves or clothing. Hair has to be tied back. That all is in that sort of realm of things getting caught and getting pulled into rotating equipment. So you have to assess whether or not there is a hazard of this happening and address it accordingly. In a nutshell, I wanted to talk about machine guarding. I broke out some e-stop information for you because I do see those getting conflated. Sometimes people try to mix those two. They're two different things, but I gave you 5 steps, real easy steps to get you started to comply with the machine guarding requirements as well as the e-stop requirements as well. I hope you got some value out of this episode. Let me know what you think. Send me an email, info@thesafetypropodcast.com. Make sure you visit our partners in safety. They help make this happen for you. whosonlocation.com and mightylinetape.com/podcast. Go check them out. Show some love to our incredible partners in safety when you get an opportunity. And until the next Safety Pro podcast episode, as always, folks, be safe.